A whole list of definitions, most of which you should already know, starting with an equation. I hope you've seen an equation once before in your life. An equation is just a statement indicating that two algebraic expressions are equal. So my example is 3x equals 6. That's an equation. Shh, don't ruin the surprise.
No way.
Don't ruin the surprise. Okay, a solution. Also called a root. So if I ask for a root of an equation, I'm actually just asking for a solution of an equation. Is the number substituted into the equation that satisfies the statement? In the one above, the answer would be 2. Or you could list it as x equals 2. Both perfectly fine answers in my class. A solution set is when you are listing all of your solutions for a particular problem. So this one, 3x equals 6, would only have one solution. So 2 would be the solution set. But if you remember from Algebra 2, there are equations that have multiple different answers for it. And to be a solution set, you'd have to list all of them. So let's make a made-up one. So we could have 3, 5, and 1,123.6.
That is like the most random number.
I don't think there's any equation in the world that has those 4 answers, that they seem too disjointed to be possible. But if all 4 answers, you have to list all of them to be a solution set. All right, linear equation. A linear equation can be written in the form ax plus b. Note it doesn't say ax squared. A linear equation only has x to the first power. That's what makes it linear. Our first example, 3x equals 6, can be written in that form because we would just write it as 3x minus 6 equals 0. It is linear. We know it's linear because it's just x to the first power as well. Solving. You are going to use properties of equality to identify the solution set. That is adding on both sides, subtracting on both sides, multiplying, dividing, taking the square root, squaring, so on and so forth to solve our problem. So in our equation, 3x equals 6, I would just need to divide both sides by 3. Then I would have x equals 2. That was a tough one. Equivalent are equations that have the same solution set. So a really terrible example would be if I had 2x plus 5x equals 6. And I also had the equation 7x equals 6. Both of those have the exact same solution set because you can see one would be a step further in solving. But they both have the same solution set. Extraneous root. This is the big guy. This is the guy you should have starred and you should pay attention to a lot. An extraneous root is going to be one that's going to look like a solution, but is going to trick you because it's not actually a solution. So my example for this one would be, let's say I have 1 over x minus 2 equals 0. And someone tells me x equals 2 is a solution. Well, x cannot equal 2. It cannot equal 2. Because if you plug a 2 in, you'd have 1 over 0. You cannot have 1 over 0. So 2 would be an extraneous solution. You know to check for extraneous solutions whenever you have a fraction where your variable is in the denominator. And that's going to be very important because we're going to have problems in the homework. We're going to have problems in the notes today that you think you're going to have a solution, but in fact, it will have no solutions because it's, bless you. It is an extraneous solution. All right. Moving on. Some using properties of equality to solve equations. So we're going back to Algebra 1, basically. If I need to get x by itself, the first thing you're going to do is, bless you, is we're going to add 4 to both sides. Yes, Nick?
Would every equation have an extraneous solution?
No. Because 3x equals 6 does not have any solutions that don't work. An extraneous root is one where you think is an answer, but actually breaks the problem. And we'll see an example later on.
Okay, like 1 over 0.
Yeah, we'll see an example later on.
Like Catherine yesterday. Oh, did I break the quiz?
No, she did not break the quiz. All right, so we have 3x equals 12. Then I would just divide both sides by 3 to come up with x equals 4. So you can either put x equals 4, or you can do a brace with 4 into it. Either one is a perfectly fine solution in this class. All right, the next one has fractions in it. For the notes, I am going to always clear fractions because clearing fractions is always a good idea. In order to clear fractions, we have to use something called the LCD. Our LCD is just our lowest common denominator. It is our lowest common denominator. What's our lowest common denominator in this guy? Nick?
4.
It is going to be 4. Now, with clearing fractions, if you don't recognize 4 being our lowest common denominator, you can always multiply your denominators out. Go 2 times 4 and 8 would be a common denominator, and 8 would work to solve this as well. So since we know it's 4, we are going to multiply both sides of the equation by 4. So I'm going to move the x to the top so it doesn't get lost. So I have 4 times x over 2 minus 6. And the other side, I'm going to do 4 times... once again, I move the x to the top so it doesn't get lost in the denominator. 3x over 4 minus 9. Well, we have to distribute this to both items. So 4x divided by 2 would give me 2x. In other words, 4 divided by 2 is 2. 4 times 6 is going to be 1224. That's going to equal, don't forget to distribute this to both things. We are going to have the 4s are going to cancel out. We'll have 3x. 4 times 9 is going to be a negative 36. Now I'm going to add, I'm going to do two things in one step. I'm going to add this 24 to both sides. And I'm also going to go ahead and subtract 3x from both sides. 2x minus 3x is going to give me a negative x. And maybe we'll do things in perp. This is going to give me 0. So it's going to equal, that's going to give me 0. This is going to give me negative, not 21, negative 12. Multiply both sides by negative 1. You have x equals 12. Our answer is x equals 12.
Oh, that's a 24.
Yeah.
That was a 2y.
Nope, it's 24 because we don't have any y's in this one. All right, questions on that one? So these are kind of brute force problems. You just got to keep working until you whittle down to just an x and a number, or a y and a number. All right, next one. We have fractions. We are going to come up with a lowest common denominator. If you can't just look at it and say we have a 2 and a 4, it must be 4, or 3 and a 9, it must be 9. If you can't look at it, we have variables in there. To come up with our LCD, we are just going to multiply the denominators. Every denominator we have, we're going to multiply together. So if this was 1 over 3, we'd have something else to multiply by. We only have a 2 and an x minus 1. So to get my lowest common denominator, we're going to multiply denominators. And in this case, we are going to have just 2 times I'm zoomed way in, x minus 1. I guess this isn't really short. So we're going to multiply all denominators. In this case, we only have a 2 and an x minus 1. So we're just going to stick with 2 times x minus 1. Now we're going to multiply both sides by that 2 times x minus 1. So we'll have 2 times x minus 1 times that 1 on that side. And that's going to equal 2 times x minus 1 times everything on the right side. So that's 1/2 plus 1 over x minus 1. Well, 2 times x minus 1 times 1 is just 2 times x minus 1. So let's go ahead and distribute the x to give me 2x minus 2. Now remember what happens here. This is the whole point of multiplying them out. If I put this on top, we'd have 2 times x minus 1 over 2. Our 2's would cancel out, and we'd just be left with x minus 1. Then we'd multiply this on top. We'd have 2 times x minus 1 over x minus 1, or x minus 1's would cancel out. So we'd be left with a positive 2 when we actually did this multiplication. Are we okay with that? Yeah.
Why wouldn't the x minus 1 cancel with the x minus 1 on the bottom?
It does. That's why we just have 2 left.
Why you still have x minus 1 up there?
Oh, here?
Yeah.
Because we have to multiply it by both things. So we have 2. So let me write this out. So when I distribute this, we would have 2 times x minus 1 over 2 plus 2 times x minus 1 over x minus 1. In this case, our 2's would cancel out. In this case, our x minus 1's would cancel out. And we would be left with 2x minus 2 equals that x minus 1 plus 2. Does that make more sense? Yeah. Yep, because we have to multiply it to both things. All right, so simplifying this, we'll have 2x minus 2 equals x minus 1 plus 2 is going to be plus 1. Let's finish this guy over here. So I would subtract x from both sides. I would add 2 to both sides, so we'd have x equals 3. So if you need to, just write this step in here. I probably will skip it because I just do it in my head. I just cancel stuff out. But if you need this step, write it in there. Remember, these are your notes, not my notes. Are we good on that problem? Make sense? Everything's good? Kosher? Cool? Yeah?
Couldn't you cross multiply too?
Where could you cross multiply, I
If you
guess?
move the 1/2.
Oh, sure. If you move the 1/2 to the other side, so you subtract 1/2, so you'd have a negative 1/2, you could then cross multiply. Yep. Make sure it's on both sides. I just wanted to make sure we were clear because some people will cross multiply here, and it's just like, no, can't do that. It has been obvious. All right, moving on. We have 3 different types of equations. We got more than that, but just for today. We have an identity. We have a solution set is every real number for which both sides are defined. What did I do as an example? I did 2x plus 5x equals 7x. When I solve this, you might come up with something like 7x equals 7x. Or you might actually come down to 0 equals 0. Both are examples of identity because 0 equals 0 is a true statement. If it's a true statement, it's an identity. So if you come up with 0 equals 0 and it's true, if it's true, it is an identity. Conditional means there's not an infinite solutions. We're just looking for 1, 2, 3, 4, or some kind of finite. So a conditional one would just be, let's go back to our classic 3x equals 6. If I solve for that, I come up with x equals 2. Because there's just one answer, it is conditional. So once again, identity is if we have both sides of the exact same, or we come up with a true statement. Conditional is if I come up with 1, 2, maybe 3 values. Inconsistent means there's no solutions to it. Inconsistent is going to be our trickiest one, and we'll see it in a couple examples that we have. But an inconsistent might be something like 2x plus 1 equals 2x plus 2. If I was to solve this, I would come up with 1 equals 2, which is false. So an inconsistent would make a false statement. And it can also be tricky. You might think it has an answer, and it doesn't because it has an extraneous root. So an extraneous root is also something you're going to look for inconsistent. Inconsistent, you're looking out for an extraneous root as well. All right, let's do some examples. This is classify the following equations. So we're just kind of hitting you with a bunch of simplification. This is, on the surface, not a hard problem, but in the details, you can mess up several places on this one. So let's try to go through it slowly. So we have 3 times x and then 3 times a negative 1. So we'll have 3x minus 3. Don't forget, in this next part, we're doing all of the negative 2x and multiplying it by that 2, which would give me negative 8x. And we'd have a negative times a negative, so we would have a positive 2x squared. That's going to equal... now, when a lot of people see a binomial times a binomial, a lot of times they kind of do that FOIL method, first outside, inside, last kind of stuff. I just think of distributing. I always just distribute in my head. I might combine like terms in my head, but all I'm thinking about is, well, what's 2x times x? Well, that's 2x squared. Stick with the 2x. What is 2x times a negative 3? That is negative 6x. Now we move on to the 1. What's 1 times x? That equals x. And finally, what's 1 times negative 3? That is negative 3. Now you might say, well, it's going to end up, FOIL is fine here. The problem with FOIL is it doesn't work on anything that's not a binomial times a binomial. So if you get in the habit of doing this, if I have a binomial times a trinomial, it's just adding an extra kind of rainbow to it. So I like this method more because it applies to everything. FOIL only works to a binomial times a binomial. All right, simplifying this, we are going to have 2x squared on this side. I'll put my highest power first. I got 3x minus 8x, which equals a negative 5x. We have minus 3. That's going to equal 2x squared minus 5x minus 3. You do not have to go any further than that. Because if you look at this side is equal to that side. These are the same. If both sides are ever the same, you can solve it. You're going to end up with 0 equals 0. But if they're ever both the exact same, you are just going to say it is going to be the identity. Because whatever I plug in for this x, for this side, has to equal whatever I plug in for this x, because it's the same thing. All right, so that one is our identity. The next one, we have y over y minus 3 plus 3 equals 3 over y minus 3. I'm going to go ahead and clear the fractions. You do not need to clear the fraction in this one. You could subtract on both sides, and you'll get to the same answer. But I'm just going to get in the habit of clearing fractions. It's usually the correct path. So to clear the fraction, I need to have my lowest common denominator, which in this case, we only have one denominator, and that is y minus 3. The only time we're going to multiply our denominators is if I have different ones. So if I had y plus 3 and y minus 3, then my lowest common denominator would be y minus 3 times y plus 3. But we only have y minus 3, so let's multiply that on both sides. So we'll multiply one side by y minus 3. Don't know why I changed that. So we'll have y over y minus 3 plus 3. That's a squiggly 3. That's a better 3. That's going to equal y minus 3 multiplied on the other side, which was just 3 over y minus 3. Let's go ahead and distribute this guy. When I distribute it to the first term, that y over y minus 3, our y minus 3s will cancel out, and I'll be just left with y. Plus, and we'll have 3 times y minus 3 when I distribute this to the 3. That's going to equal, once again, our y minus 3s are going to cancel out, and we're just going to have it equals 3. Working our way down, we'll have y plus 3, y minus 9 equals 3. That's going to give me 4y equals, well, I'd add 9 to both sides, equals 12. Divide both sides by 4, and we're going to come up with y equals 3. This is an inconsistent equation. Who thought it was conditional? You thought it was conditional because it came up with, what's up, Liam?
Will and I would like to do our test.
No, I'm teaching. We have y equals 3, right? So it looks like it's conditional because I came up with one answer. What happens when I plug 3 back into the original equation?
Oh, it cancels out.
I will have 3 over 3 minus 3, which is 3 over 0, which is undefined. So it's inconsistent. This is actually an extraneous solution. And it's an extraneous solution because if I were to plug it back in, for y minus 3 over, it was y over y minus 3. If I'd plug that 3 in, we'd come up with 3 over 0. Nope. It's an extraneous solution, is inconsistent. Like I said, inconsistent is going to be the trickiest of the 3 because you're going to immediately go into conditional mode and say, oh, I got an answer. Check it, plug it back in. This is important stuff. I guarantee you people are going to get this wrong on the test. I say that because I know it's going to happen. Prove me wrong, everyone get it right, but I'm not proven wrong very often. I could pretty much guarantee we could have a pizza party if everyone got this inconsistent. All right, our next one. We are going to note something at the top because there's a key to solving this problem. Note. And the note I'm going to put is x squared minus 1 is actually a perfect, or a difference of squares. Where x squared minus 1, we could think of that as being x squared minus 1 squared, is going to equal x plus 1 times x minus 1. That is really important. It's really important because let me show you what's going to happen if you don't recognize that. If you don't recognize that and you come up with your lowest common denominator, you're going to say your lowest common denominator is x plus 1 times x minus 1 times x squared minus 1, and you're going to make a really difficult problem really quick. Instead, if you recognize the fact that that is a perfect square, you could say x plus 1 times x minus 1 actually equals x squared minus 1. What that lets me do is it lets me multiply the left side by x squared minus 1 and the right side by this because those two things are equal to each other. We're still multiplying by the same thing on both sides. So let's go ahead and do that. So we'll multiply the left side by x squared minus 1 times 2 over x squared minus 1. And we're going to multiply the left side by the alternative x plus 1, x minus 1. And once again, we can do that because they're both equal to each other. I'm still multiplying both sides by the same thing. However, by changing the look of it, these now cancel out. So I can now cancel out this, and I'm just left with 2 on the left-hand side. Let's go ahead and distribute. When I distribute the right-hand side, we're going to see that we have x plus 1 times x minus 1 all over x minus 1. So the x minus 1s will be canceling out, and we'll be left with x plus 1. Now we're going to have x plus 1 times x minus 1 on top of x plus 1. So our x plus 1s will cancel out, but we do have that negative sign, so we'll have negative x minus 1. Are we all okay with that step? Because I did a lot in my head there. Yes?
Can you re-explain the right side again?
Sure. I guess I can write it out again. I just don't know how much space I left. So my right side is going to be x plus 1 times x minus 1 all over x minus 1 minus x plus 1 times x minus 1 all over x plus 1. My x minus 1s and my x plus 1s will cancel out.
Okay.
And then we have 2 equals x plus 1 minus the x minus 1. So in fact, we'll have 2 equals x plus 1 minus x plus 1, which if we solve that, we're going to come up with 2 equals 2. 2 equals 2 is a true statement, so it is going to be an identity.
35 is exactly the same.
Thank you. That means you can try it on your own and see if you can match the key right. It doesn't mean just copy it. All right, so last thing we need to talk about are absolute values. So we are covering kind of more ground than it looks like we're actually covering. Absolute values. I'm not going to say anything, but I'm going to circle this guy. This guy is going to be your most important one. I think we fully understand that if I have like absolute value of x equals some positive number. So say we have absolute value of x equals 9. X could either be negative 9 or positive 9, because the absolute value of negative 9 is a positive 9. Absolute value of 9 is a positive 9. Absolute value of x equals 0. X has to be 0. This is where I can not trick you, but I can put what looks like a very difficult question that's super easy on the test. I can give you something like the absolute value of 59x squared times the square root of 39x equals a negative 2. As soon as I say an absolute value equals a negative number, you have to immediately know there is no solution. All right, so anytime we have an absolute value equaling a negative number, it is going to be no solutions. That's really important because I can bury that on the test, and you'll have some people that fill out the whole block with a whole bunch of work and lose a whole bunch of points versus someone that just puts no solutions or a circle with a line through it. So be aware of that. All right, example A is absolute value of x minus 5 equals 4. This is how I do this. I split it. I split it into two possible equations. I have either x minus 5 equals a negative 4 or x minus 5 equals a positive 4. It gives us two equations to solve, and I'll go through why this works. So we add 5 to both sides. We have x equals 1 or x equals 9. Or you can write the solution set as 1 comma 9. I don't care how you write it. I just want the answer. Let's double check to make sure this method worked. If I plug a 1 in, we'd have 1 minus 5 would be negative 4. Absolute value of negative 4 is a positive 4. If I plug a 9 in here, 9 minus 5 is 4. Absolute value of 4 is 4. Yeah. Oh, I'm sorry.
No, I'm not raising my hand.
Yep. I just saw movement on the corner of my eye. All right. For our next one, in order to do this method, your absolute value needs to be alone. it needs to be alone. How did I put it? Did I put anything clever? No, I just put get alone. We need to get this alone. In order to get alone, we treat it like a variable. We treat it like it looks like 2x minus 6. So the first thing I'm going to do is I'm going to add 6 to both sides.
2x minus 6.
Which is going to give me 2 times x plus 8 minus 6. And then I need to divide by that 2. Maybe I'll do that in that blue too. Oh, not negative 6. It's positive 6. I don't know where that is. Don't worry, I got rid of it. I got rid of that little guy. Bless you. Equals 3. So that branches off into two possibilities. Either x plus 8 equals negative 3, or x plus 8 equals a positive 3. If x plus 8 equals a negative 3, then x equals a negative 11. Or x is going to equal a negative 5. If you plug that into the equation, you will get the correct answer out. Yes?
Why does it matter if we take the 2 away from the x plus 8? I got the same answer.
Just do it.
Okay, like, I mean, I get it for exponents, but...
It's just nice to get everything all by itself and split it apart. Especially if there's like a negative 2, well, even a negative 2. It's just, it makes more sound sense to remove it, but it still works with it being there. I like to remove it too because then I'm just dividing by 2 on both sides. Here I actually have to do it twice. So if here I had 2 times x plus 8 equals 3 and 2 times, I have to divide 2 twice versus just once. All right, questions on anything we covered today? We actually covered more than it looks like. There's basically a whole chunk of algebra just covered today. All right, so the best thing you could